Ladies and gentlemen, this is Ghulam Mustafa Abro, and the topic of my presentation is prototyping IoT-based smart wearable jacket designed for securing the life of coal miners. Representing Hamdard University, Pakistan. These are the table of contents. We will be discussing the abstract, the introduction, the problem statement, and we'll be touching some current state of the art approaches for proposing the solution of this particular problem, discussing the proposed solution of my presentation in terms of block diagram. And this is not an end. We will also discuss some hardware design, and we'll discuss somehow the results that we have actually derived from our particular solution. And last but not the least is the conclusion, and we'll be providing some list of references as well. So before going for abstract, I would like to highlight the situation of coal mines within Pakistan. In this picture, you can see that people are working uh, in a very strange environment where they don't have much more facilities over there. So you can see that they are actually working in a very unsafe environment. And once this cave or this mine is going to collapse, then it would be uh, they will be dragged to a dark mire actually. So this is something that was a concern, a problem that we highlighted, that how to save these coal miners who have no option except working in this environment to run the show for their family. So, keeping up this particular scenario and problem in our mind, we provided a solution. The abstract of our proposed solution is starting from a responsibility that as an engineer, as a student of science, technology, engineering, and mathematics, we should be providing an alternatives, those alternatives that can meet the scarcity. So in Pakistan, there are several number of cases reported where people died actually, and many of them were injured, and many of them were like enchained beneath this ground for several days without any food and water. So keeping up this particular scenario in our mind, we propose a solution that is based on IoT, a wearable smart jacket that can track our coal miner and may tell us the whereabouts and the health status of a coal miner, so that we can take a precautionary measures for him or her. There are some female workers over there also. They are supporting in terms of providing the food and all these things. So we were like very much into this topic to propose something that should save, at least provide a way out for rescue team, so that they can dig up and they can rescue some of the coal miners in any emergency state. So moving further, you can see these are the cases. This is a very serious issue that have been highlighted for many years, and still we have been hearing some of the cases in our newspapers and in our electronic media as well. So over here, if you can see, I'll be focusing the country Pakistan, because the entire project is actually proposed for the Pakistani situation. So over there, you can see that this is in Urdu, where 13 people were, died while working in a coal mine. And this is not an end. Many countries like China and many other countries, they are actually focusing on this area to propose something that should be better for the rescue team, so that they can rescue some of the people in a very short time. So in proposing such solution, it was mandatory for us to go for a literature review. So you can see that the state of the art approaches that we studied are eight. One is ubiquitous computing method. It is highly complex algorithm which you can, yeah, which you cannot amend it, and when you are implementing it on any coal mine, it requires serious changes in the algorithm. The second one is audio communication based system where you use walkie talkie or any other medium, but it is like not reliable in our scenario where you can easily lose the connection or communication. Smart wristwatch is actually one of the best solutions so far, but the thing is mobile communication is not possible beneath this ground. And the other thing is these workers are not literate enough to use those smart watches and can easily communicate. Fourth one is microcontroller and amalgamated Android applications that are very popular in today's era. But again, our miners are not accustomed to smartphones and literacy rate in Pakistan, especially those areas where the coal mines are situated. Moreover, the best technology, like the better standard, the benchmark technique is average slope multiplication techniques. But again, it consumes a high processing time while locating the miner. Low frequency magnetic communication system is very much into in this particular trend, but the thing is it causes and it can be a cause of a cancer as well. So low frequency magnetic communication is hazardous to health. Moreover, the seventh technique is MEMS based sensor deployment, which is expensive and you cannot find much of the sensors based on MEMS principle that are deployable in such scenario. So you have to fabricate them by your own. Last but not the least is robotic autonomous systems where you send any robot, any unmanned ground vehicle to locate or any rover. But the problem in these coal mines are they are not linear, they are not uniform actually. And this is the reason that our robotic autonomous systems are also cannot track the miners or cannot locate them easily. Moving ahead, after visualizing and after studying this brief literature review, we come up with a methodology that you can see in a block diagram. We actually propose some of the market, some of the sensors which are available in the market. You can see DHT sensor. This sensor is actually the temperature sensor. You have pulse sensor already available in the market. You have gas sensor. This one is the MQ5 gas sensor, which is like available in the market and it can detect any hazardous gas. You have depth sensor, which actually shows you or which measures or which can fetch actually longitude and latitude coordinates for a miner. And then you have GPS module again, which will definitely provide strength to our device in measuring the location. And last but not the least is ESP8266, which is Wi-Fi shield. So what will happen if you see on the block diagram, all the sensors will acquire the data and will send to Arduino Mega 2560 controller. Once the data is received, then we will be sending it to our IP address, which is actually the static IP address. And then you can use IoT broker as well. Like the free IoT broker is available in the market, that is Connect Things. So you can make a proper display over there and you can see each miner, the status, the health status of each miner, the location and everything. But in our case, as we were like proposing a prototype, we just displayed all the information on an IP. And this is the methodology and hardware components that we suggested at this stage. Afterwards, our primary goal was like main focus was to fabricate in a device. So since we were in the early stage, we never fabricated into a small device, but rather than we pasted all the components on an acrylic sheet. You can see this acrylic sheet pasted with the jacket. It was an early stage when we were not focusing on the size. So you can see that this is the big hardware design, but it can be reduced in terms of size into a small box. Even we have Arduino Nano available in the market where you can interface it and it will do the same work for you. So these are the batteries, and you can see the battery, and it's somehow not properly portrayed because still we are doing research on it so that we can make it, a better way. We can come up with a better way. So I'll share you what are the future works that we are doing on this design. But before this, I would like to show and demonstrate the results. So you can see over here, Hamdard University height stands for Hamdard Institute of Engineering and Technology. And over there you can see that we actually, one of our teammates who carry this jacket, and we actually acquired the pulse rate, the latitude and longitude, the temperature and the altitude as well. And one stage there was no gas detection, so you can see that there is no gas detected. And in this particular picture you can see that longitude and latitude values, which are actually the location for Hamdard University. So what we did, actually, we actually tied the jacket with a rope, and we went on a top of a building, and then we gradually, like, leaving the jacket towards the ground, and the altitude was changing at itself. The question over here can be asked that how it is going to be viable in a coal mine. So for a coal mine, it is suggested that if you have a base station and you can amalgamate this particular scenario with the world, with the wireless sensor networks or wireless sensor nodes, then it can be one of the best, one of the better fits, actually one of the better suitable solutions for saving the coal miners, actually. So the idea was simple. Like, many people were dying, and it was a personal experience which we actually, our team members, faced when we visited one of the areas of Pakistan where we saw some similar tragedy. And over there, as an engineer, as a student of science, technology, and engineering mathematics, it is obligatory on us to spend some time to come up with some solution, some alternative that can meet some scarcity of a social problem. So this was one of the social problems that we faced, and we come up with a solution that we should come up with the IoT based smart wearable jacket design that will share the health status of a coal miner, the location, so that in any case if the coal mine is collapsed, the rescue team can come and see the data. Okay, what was the last time, what was the recent altitude of a coal miner, and as per the medical conditions, where we can start digging and can rescue the maximum people from the coal mine. So that was actually the idea. And no doubt this idea was supported by a higher education commission, the government of Pakistan, and we were actually sponsored for this project to present it at the University of Essex, Southend, United Kingdom. And apart from that, I really want to acknowledge Engineer Asim Raza, one of the senior faculty members of Hamdard University, who helped us in conducting some of the series of experiments to propose this prototype. And lastly but not the least, I said you that it was a personal experience, so I really want to dedicate this work to Mr. Bakht Nazar, who died in one of the similar tragedies after working 30 years in unsafe mining conditions. May Allah bless his soul, rest in peace. Apart from that, these are references. The future work is like, at this moment we are actually monitoring all the things. So future work is to come up with a proactive approach, so that the coal miner can itself, like himself, can just press a button, so that we can learn, we can know that okay, he is not feeling well, so we should send our team to rescue him before any emergency or any uncertainty case. So this is all from my side. I really thank for this platform to highlight one of the important topics that we faced. I hereby open the floor for question and answer session. Thank you so much for listening.